Welcome back to the Doughnut generator tutorial. In the previous episode, we started from nothing and made the Doughnut geometry made entirely with nodes. If you've missed that, go and watch that video because we're gonna use this as a base for this video's task, which is the Doughnut glazing. So, let's get to it. Right, we have the Doughnut from the last video. And what we're gonna do is make a duplicate of half of its geometry and use it as a base to build the glazing from. How can we do that? Well, you may have thought a duplicate node, great thinking, but actually an easier way, we're gonna grab a copy of the entire Doughnut and just delete the bottom half, leaving us with the top. However, first things first, I'm gonna lower the resolution for now. Blender's gonna work faster and we don't need all this detail in the glazing. Speaking of which, we're not gonna copy from here with all this stuff. We're gonna copy from somewhere around here, before the center line. All of this adds fine details which we don't need in the glazing. So I'm gonna drag straight from here and bring a delete geometry node. Okay, as of now, it deletes the entire thing, so you may have seen this selection option, which does what it says. It selects which part of the geometry is going to be deleted. Now, in regular modeling, selection is trivial. You just select what you want and then delete it. But in geometry nodes, we have to actually feed something in here that will do the selection. What could that be? Well, you can see this socket is pink, so that's a boolean, which makes sense. Any part of our mesh has two options, selected or not, true or false in terms of the boolean, and in terms of the visuals, white will be selected and black will not. And this is actually a very big part of geometry nodes. You see this selection in a lot of nodes, and it's a very common pitfall for beginners. If you ask me, I think half of the art of geometry nodes is knowing how to select what you want. And there's no one single way of doing it. It's gonna be very dependent on what kind of geometry you're working with. For this Doughnut, we're gonna need to select the bottom half so that we can delete it. So let's see how we can do that. If we use the vertical gradient that we've made in the previous video, remember, this goes from 0 to 1. We can say that anything less than 0.5 should get deleted. For that, we can use a compare node. If we plug our gradient into the top socket, the compare node will output true for any value of our gradient that satisfies this condition. In our case, we want less than 0.5. There you are. Previously our gradient, then we compare it and it looks like this. And we can move this boundary up and down by changing the second value. Now anything that is white will get deleted and the black will remain. So let's plug this into the selection, and there we are. We have a base for our glazing. This we can make into a control. I'd say we can limit this from about 0.4 to about 0.8. I'll call this glazing height. Okay, there is a slight issue where it looks kinda jaggedy. And that's because we are sampling this deformed Doughnut, which is gonna have slight unevenness in the height of its vertices. So at the boundary here, there's gonna be some points that are above this value and some points that are below. To solve this, we can sample our gradient from the original torus, because it has perfectly level rows of vertices, so they all share the same height. There's not gonna be any unevenness. So that's the base. Now we need to extrude the base to give it thickness. So go ahead and search for an extrude mesh. Okay, straight away you're gonna see it looks really weird, kinda like a hedgehog. That's because it extrudes each face individually. So uncheck that. Let's also lower the scale. And it extrudes it, but you notice this lip down here. This doesn't contain the base mesh. It just extrudes it outwards. But what we want is to solidify this, to give it thickness. So we're gonna need a way to add the original base back into the geometry. And also, I want to add cuts to this rim so that we don't have these long faces here. That could be useful. So let's address this first, because it's gonna allow me to show you something very cool added as of Blender 4. I'm gonna add a grid here, which is just a plane. I'm gonna extrude this, okay? Now, if I want a cut here, what I can do is extrude this top face again, and it should leave us with an edge loop in the center. So let's see. If I copy the extrude, we have something that looks like a box, because we are extruding each face again, but we wanted just the top face. Thankfully, we have a top selection from the previous extrude, so if I plug this into the selection of the second one, we get what we want. We've extruded this face twice. And if I do this again, we have 3 stacks and 2 cuts in the middle. But this is a bit of a pain. We have to repeat this extrude node over and over again. Thankfully, in Blender 4, we have a very useful tool called the repeat zone. This will do essentially the same thing. It will repeat any node that is inside this zone, and we can determine how many times from this iteration setting. So we can place the extrude node in between these two, and then we can connect the repeat zone like this. Now, to connect the top back into the selection, we need to connect it to the repeat output. Then it will show in the input, and we can connect it to the selection. We just need to set it to true from this. Now I can just increase this, and it will keep repeating the extrusions. However, it keeps stacking them on top of each other, whereas we want to maintain this height and just have these cuts appear in the middle. We can do that by dividing this height by the number of iterations. So I'm gonna bring up an integer for the iterations and a float value for the height. Now we need to divide the height by the number of iterations. And just like this, we can set the offset and the number of cuts. Now we need to combine this geometry with the original geometry. For that, we're gonna use a join geometry node. This has a very special wide socket that can accept many inputs. So we can plug the extrusion and the original mesh, and this will combine them into a single geometry. However, there's a slight issue where the points here will overlap. There are 2 points here on top of each other. So we need to merge them with a merge by distance node. And I'm gonna give one more 0 to the distance to make sure that this is very, very small, so that only points that are right on top of each other get merged. Okay? Let's make this into a group. I'm gonna move the geometry to the top. The value I'll rename to offset scale, and the iterations will be cuts. Tab back out. Let's name the group Solidify Mesh. Okay, but the number of cuts now says 3, and there are 2 cuts. So inside the group, we need to add 1 to the number of cuts. If I hold Shift and right-click, drag, I can drag over these 2 lines and combine them with a reroute node. Now add to this 1. If I select this and press Ctrl X, it will dissolve the node and reconnect all the other noodles. Now this displays the correct number of cuts. Let's output the selection as well and reconnect back these noodles. Now this offset here is the direction of the extrusion. By default it uses the normal of the face, but when we output it, it is now a 0, 0, 0 vector. So that's why we don't see anything here. This doesn't have any direction. So we have to set up logic inside our node group such that when this vector is the 0 vector, use the normal. Use another compare node here. Make sure it is set to vector and equal. So when this vector is equal to the 0, 0, 0 vector, output true. This here is the precision. Set it to 0. Next, we'll use a switch node. Set it to vector and connect our condition. So if this vector is 0, this will be true. So use the normal. If it's not true, use whatever comes from this socket. And we should probably normalize this vector because I want it to only show direction, no scaling. This will make its length equal to 1. Using this setup, we fix that issue, and now we can plug any vector in here to serve as a direction for our extrusion. Let's bring our offset scale under this socket. Next, I want a control for whether to include the base of the mesh or not. After all these, I'll add a switch set to geometry, and I'm gonna switch between all these or just the extrusion. Then output this switch and call it include base. We just have to switch the order of the switch so that when I check it, the base appears. I want to have access to all these selections, so the top is easy. We just output this. Now I have access to it from the group node. I also want a selection for the base. The way I'm gonna do that is here, just to the base geometry, I'm gonna add a capture attribute node. That attribute should be set to face, and it's a Boolean attribute. And then make it true. Now we output this and call it base. Let's see if it works. Yep, we have a selection for the top and a selection for the base. Now, to make a selection for the side, what we can do is combine both of these selections with a Boolean math node. This has logic operations, and what we want is the OR operation. The OR is used to combine two selections, like this. Now duplicate this and set it to not. This will invert everything. And now, effectively, we have a selection for the side. So output it. Let's now check if everything works. We have a selection for the top, the base, and the side. And we have a very good solidify node with the option to add loop cuts to the side. So let's use it to extrude our base for the glazing. There we are. We want to include the base, and I'm gonna give it around 3 cuts. Just one more thing. If we see the face orientation, the base is inverted. So inside the solidify, add a flip faces node to the base geometry. This will fix it. Now we can make a control out of the offset scale. For this, we can set it from around 0.1 to around 0.3. I will make this glazing thickness. Now, right now, we have a control for the height of the glazing and for its thickness, but it's a bit too straight. I want a way to add waviness to this glazing, so it's a bit more interesting. So here's my plan. I want to make a radial noise field like this. Then we can use this radial noise to move the boundary of the glazing up and down. To make that radial noise, I'm gonna go all the way back here to the main curve circle. I'm gonna apply the noise to it and then transfer that noise to the donut. So to the main curve circle, I'm gonna capture attribute. Then to the value, I will add a noise texture. You probably won't be able to see this, but if I preview it with the torus, see we have this radial noise field. I will group both of these. Let's set the noise texture to 4D. We don't need any detail. And output its scale and the WC. Then get that attribute to the group output. Okay. This node I will call curve noise. Now, the way we're gonna create this waviness, here, before we give it thickness, I'm gonna add a set position node. What we want is to move just the edges of the glazing up and down on Z based on this noise field. But I don't want to move the entire glazing, just the bottom edge. For that, we are going to need to mask out the top of it. We could use our vertical gradient and make it white on the bottom and black on the top. For that, we need to invert it. To invert a normalized range, we can just subtract it from 1. The reason this works is if we have a range from 0 to 1, if we subtract it from 1, this will be 1 minus 0, so 1, and this will be 1 minus 1, so 0. So we end up with an inverted range. Then let's use a power function to really focus on the white part. Increase the exponent, and this will be the mask for our noise. So to our offset here, we can plug a combine XYZ node, then plug our mask into the Z, and make sure the X and Y are set to 0. Then we can scale this vector by our noise field. Right now, our noise is normalized, so let's use a map range to make it from -1 to 1. Also, let's multiply it so we have a control over the waviness strength. We can make this into a control, glazing waviness, and I'm gonna make it into a fact type from 0 to 1. Okay, but the way this is set up right now, the inside of the glazing is like a mirror image of the outside, which doesn't make much sense. Ideally, the inside noise and the outside noise should be independent from each other. So what we need is another mask that just masks out the inside from the outside. For that, we're going to need another gradient, but this time it should be a radial gradient from the inside out. For the vertical gradient, we measured the z position of the points. The position of any point is a vector from the world origin to its location. So if we measure the length of this vector, ignoring the z, we will get short vectors on the inside and long vectors on the outside. So let's get the position, multiply by 0 on the z, and the other two by 1. That way we get rid of the z component. Then we can measure the length of this vector. This is another vector math node set to length. And finally, we normalize the length, plug our geometry, and it will give us our radial gradient. Now, I want to show you something else. Instead of making a black and white mask with a compare node, we can make a contrast node. If we plug our gradient into a map range node, then bring these from values closer and closer to 0.5, the gradient will become more and more contrasty. But if they're both 0.5, it won't work. We need to leave some room, so the minimum will be 0.499 and the maximum will be 0.501. That way there's no ambiguity. Then we can make this a control with a mix node from 0 to 0.499. Then if you notice, this one is 1 minus 499. So we get that and subtract it from 1. Now, this is a contrast control. Pretty handy. Let's make it into its own group. Output this and call it contrast. The node group, also call it contrast. Now we group all these, output the contrast, and the group we will call inside-outside mask. There we are. Now we can use this as a factor for a mix. Then I'll make another copy of the curve noise. I'll frame each of these. The first one will be inside noise, and the second one will be outside noise. Okay. Then we plug these two noises into the mix node. And now we have two different patterns on both sides of our glazing. Because the inside is smaller, I'm gonna decrease the noise scale to about half than what is it on the outside. Okay, looks good. While we are here, let's have the waviness seed as a control. That way we can make variations of our glazing. Next, to make this cooler, we're gonna make these drips that drip from the glazing. It's gonna make it more oozy. To do that, first, you may have guessed, we need to make a selection. What we really want is to select some of the faces on the rim of our extrusion, and then we're gonna extrude those faces down. For that, we can repurpose our noise here, and to make a selection, we can threshold it with a compare node. We're going to use a less than function. With the threshold, we can set how wide our drops will be. Something like this, okay? Using the less than, we will get only the lowest parts of our wave, which is where it's most likely for the drops to form, from the lowest parts of our glazing. Okay, but right now we are selecting points, whereas we want to select faces. That's why this selection looks a bit fuzzy. To fix that, we can use another node called evaluate on domain. I'll drop this on the noise and set the domain type to face. There we are. Also, we want this selection only on the rim. We don't want it up here. Thankfully, we've created the side selection from our solidify node. And we basically need the intersection between these two selections. To get that, we're going to use another Boolean math node with the AND operation. This is going to be true in the faces where both of our selections are true, so at the intersection. And there we are, we have a selection for our drips. Now we need to extrude them down. So let's use our solidify mesh node. This will be our selection. We don't want the base, and we want these to extrude down. So I'll bring up a vector, and I'm gonna type -1 in Z. That means downwards, and plug that into the offset. With the offset scale, we can determine how far we want them to drip down. I'd say about here, about 0.15. And I'm gonna give it about 4 cuts. Now, this geometry here is very blocky, as you can see. We need to smooth it up. Sadly, there is no smoothing node, so we're gonna have to build our own. To do that, first we need to set position. Then, if we plug the position field into the position here, right now this is not doing anything because we are setting the position of each point as its own position. But what we can do in between these two is we can blur this attribute. Now watch, as I increase the iterations, you see the mesh starting to smooth really nicely. So let's make this into its own node. We want an input for the iterations and the weight. Okay, let's call this smooth geometry. Last job here is, I want to slightly inflate these drips on the bottom, because some of these are quite thin, and it's gonna look better if they are slightly thicker on the bottom. If we set position to the geometry, we can connect a normal field to the offset. Then if we scale the normal, effectively we've created an inflate function. Let's group this, make an input for the scale, and call this node inflate geometry. Now we need a map for the bottom of the drips. We can utilize the top selection from our solidify, and then we can smooth this selection up the droplet with a blur node. Make sure this blur node is set to float. Looking like this, I'd say about 50 iterations. Okay, now we multiply this and plug it into the scale of the inflate. With the multiply, we can set some value that looks good for our droplets. Something like this. Cool. Now let's join the glazing geometry with the rest of the donut using a join geometry node. One final thing I want to address. Right now our glazing looks like it's sitting on top of our donut, whereas I think that it will look better if it's hugging the donut a bit more. We can mimic that by insetting the glazing slightly inside of the donut. To do that, we can go back to the glazing base and we can use our newly created inflate geometry on it. If we use a slightly negative value, it will inset the base inside of the donut. So adjust this value until you think it looks good. Something like this. Lastly, because we've reduced the resolution of the mesh, we lost a lot of detail in the donut. To bring it back, after we make a copy for the glazing, we can add a subdivision surface node. Increase the level until you see the detail back. Okay. And there we are. We've successfully created an oozy glazing for our donut. We can control the amount of glazing, the thickness, how much waviness there is, and we can make infinite variations of it. If you want any control from the node tree, by now you should be able to know how to bring it out in the modifier. In the next video, we will make all the toppings for our donut. So, see you there.